Okay, here are your video solutions for the test review chapter 7. First question says the average cost for Valencia students for a credit is $99. So for Valencia students, it's $99. But the average cost for all college students is $150. So all college students, $150. So in this case, the population is the larger group, the all college students, and the number that describes all college students to population is the parameter. So that would be mu being 150. Then Valencia students is a part of all. Even though they're both large groups, Valencia students is part of all. So that would be the $99. That would be the sample. That would be X bar equals $99. Now, if I want to make up another example, like in question 2, I could say 30%, let's say 30% of all Americans wear glasses. And then I can say 25% of 500 Americans wear glasses. So in that case, all Americans would be the population, and the number that describes that would be 30%. So the parameter would be 30%, but since we're talking about a proportion, we use P equals 30% or 0.30. The statistic, which is from the sample, 500 Americans, would be the 25%. So P hat would be 25%, which is 0.25. Okay. Now, the next topic is talking about bias and variability. Remember, bias talks about how close your samples are to the population mean. Variability, how close your samples are to each other. So if we call the bullseye the population mean, high bias would mean the samples are far away from the bullseye. But low variability would mean that the samples are close to each other. So we'd have samples that are far from the bullseye but close to each other. Far from the bullseye but close to each other. Now, if we had low bias, that means it's close to the bullseye, but high variability, but they're far away from each other. So this would be that they're far away from each other, but they are around the bullseye. So it's low bias because it's around the bullseye, but high variability because they're far from each other. Now, if we were looking at numbers, so the average price of all new tablets is $400. The bullseye would be the $400. And then if we look at the samples, 390, 375, 425, 410, 405, 415, 385, 399, those samples are close to 300 and close to each other. So we would have low bias, close, their samples are close to the 400, the population mean, and low variability, the samples are close to each other, If we had the hourly wage for all state employees is $15, the bullseye would be the $15. And then we look at the samples. Notice that the samples 30, 75, 100, 150, 275, 500, 385, 405, they are far from 15 and they are far from each other. So since it's far from the 15, that would be high bias. Since they're far from each other, that would be high variability. Okay? Now, as far as the matching, P hat, well, actually, let's go this way. The population parameter would be P, population parameter, P. The population standard deviation, would be sigma. The population proportion, so the population parameter, is mu. Sorry about that, mu. Because we're not talking about a proportion. The population proportion would be the P. The sample mean would be X bar. The sample standard deviation would be the S. And the sample proportion would be P hat. So remember, population parameter is mu. Population standard deviation is sigma. Sample mean, X bar. Sample standard deviation, S. Population proportion, P. sample proportion p hat. And now some vocabulary. Okay, so of size and individuals from the population chosen in such a way that every set of individuals has an equal chance. That would be the SRS. Okay, Z equals p hat minus p over square root of p times 1 minus p over n. That would be your Z formula. That is your Z formula for proportions. Comment cards, call-in surveys, those are examples of a voluntary response. People refusing and hanging up the phone, refusing to answer, that is non-response. P hat plus or minus Z star times your SE, that would be your confidence interval formula. If some basic conditions are met, then the sampling distribution for the sampling proportion is close to normal. That is the central limit theorem. And then the square root of p times 1 minus p over n, that is your standard error formula. That is your standard error formula. And surveying those who are easiest to reach, that would be your convenience sample. Convenience sample. Okay, so those are questions 1 through 8.